Well, thanks for being here. I kind of looked at our application, the little mobile app for the number of check-ins. It still shows 2. There's definitely more than 2 of you here. So today we're going to talk about some of the Couchbase best practices, and I'm going to include lots of references in this presentation because you're going to get all the materials after the conference is over. So that will enable you to just kind of go in there and being able to just click on those links, and it'll take you to the areas that talk more about the best practices for particular steps in deployment and management of your Couchbase clusters. So the title, Managing a Healthy Couchbase Server Deployment. We actually get a good history of doing the whole healthy stuff. So if you go online and look for Couchbase Healthy, there's going to be several presentations. So sure enough, we're not real doctors. We're Couchbase doctors. But it started back in 2013 with Dr. Anil Kumar. He is actually here today. He's going to be presenting some things about our Kubernetes operator. So that's what he's been recently busy with. Now, there was Dr. Justin Michaels back in 2014, and then Alex Ma, who is also here today. You can see him in the hallway, talk to him, very knowledgeable guy. So again, those are links included. There's still some relevant material that you can actually gather from those presentations, but as you may imagine, over the course of those years, we invented and added so many new features to Couchbase platform. Some of this is just not going to be relevant. So for historical purposes, the Couchbase healthcare, that's what this slide is dedicated to. OK, so I assume most of the people in here are DBAs or sort of like the, at least partly DBAs, maybe DBA and the developers. So the life of DBA can be described in 5 verbs, right? You're sizing your clusters, you install in Couchbase, you monitor, maintain, and you drink, OK? The drinking will be here at 6 p.m. today, so you can definitely do that. All right, so let's jump at the first thing, the sizing. So if you want to size the cluster, again, there's probably a different level of familiarity with the Couchbase here in the audience. So just wanted to bring up this slide. We do talk often about multi-dimensional scaling, or MDS for shorts. So on this particular slide, we see the representation of a 12-node cluster. So the way Couchbase platform evolved is that we started with our data service, what was responsible for key value operations, memory-first architecture, auto-sharding, all that jazz, including XDCR, the cross-data center replication. So that's what we had up until version 4. Now, in version 4, we started adding new services to enable you to work with your data in multiple other ways, not just by using the key values. So that's how we added our NCL, the query, the SQL query language. And with that, we introduced 2 additional services, query and global index. So with version 5, we introduced full text and analytics, which is currently in beta. And you can go to some of the sessions that talk about how analytics is going to be shaped for version 6 and 6.5. So these are different services. There's actually another one that is missing here. There's an eventing service, which was added in 5.5. You can loosely think of that as triggers for NoSQL data. So the way our platform works is you can run all those services on the same node, which will probably be a very bad idea because every service uses system resources in different ways. Hence the concept of multidimensional scaling. All those additional services, they still depend on your data service. I mean, you need data to work with it, right? But the way you deploy, the way you shape your cluster depends on your particular use case. Sometimes you're going to have more of a data nodes and not as much of a query load. Sometimes it's going to be the other way around. So depending on that, when you install your Couchbase nodes, you can select which particular service or services you run on that particular node. So that's the whole concept of multidimensional scaling. You scale a certain dimension of your cluster depending on your particular use case. So with that in mind, when you are sizing the cluster, right, that's what you need to consider, how many of each nodes you will need. And there are certain ways of how to size it for different services. So again, our documentation team has been really hard working, and they actually fixed lots of things that we didn't like about documentation. So these links are included in here for your reference. If you are working on sizing your cluster, by all means, go to our documentation page and see the logic behind it, how it's being done, all right? So in addition to that, you can always involve my team. We are the solutions engineers. We work with our prospects and existing customers, as well as support. We can help you with sizing your cluster. Okay, so as far as the load distribution, well, these are our recommendations, that all your data nodes must be the same size in the cluster. And the reason for that is, when you set up the quota the memory quota that you use, they are set up on a per node basis. So if one of the nodes has 32 gigs of RAM and another one is 16, and you're attempting to set up the 32 gig quota, the 16 gig node will not be able to even work in your cluster. Or if you actually set up the 16 gig quota, so you include the smaller one, or on the bigger one, you won't be able to use all the memory for data services. So they just, for data nodes, make sure that you use the same kind of nodes. Query, preferably the same size, but what's most important for the query, and we're going to see it actually on the next slide, is CPU. So that, and the indexes, those nodes can vary depending on which indexes you actually designate to which node. Now this table is a good representation of how each of our services uses the system resources, okay? So again, it's going to be included, and it's like, thanks for taking pictures and all that, but it's going to be included in the materials that we give to you. So this is a good guideline on how you should pick your nodes, especially if you're working with the cloud service, right? This will enable you to optimize your cluster topology as well as your cloud spending. So you actually select the proper instances for each different type of node for Couchbase. And right there at the bottom, we're just talking about rebalancing. Rebalancing is not a separate kind of node, but it's just good to know that it's a pretty expensive operation in terms of system resources. And there are some ways to optimize it, but overall, it actually requires pretty much all the resources that you have in your cluster. Rebalancing is the moving of the shards or virtual buckets, vBuckets, between the nodes when you change the topology of your cluster. So if you add an extra data node, if you remove several data nodes, if you fail them over, rebalancing will be necessary to assure that your cluster is in a balanced state, which basically means you have the same number of active shards or vBuckets as you have the replicas. Okay, so just to follow up with that table, it's like if we're looking at deploying your cluster in the cloud, this may be helpful to just kind of see what kind of instances you would deploy for a particular node. So, all right, so much for sizing. Installing, and I also only have a couple of slides there. Depending on what you're installing on, since Couchbase can run on bare metal, it can run on any of the popular cloud platforms. We can run in Kubernetes now, on either open source Kubernetes or OpenShift version of Kubernetes for Red Hat. The next versions of our Kubernetes operators will cover other systems that are using that, like like the EKS for AWS, the AKS Azure Kubernetes service for Azure, etc. So VMs, containers, again, we run in all of them. You can move the data between those different environments, but the deployment specifics for every platform are different. So there's absolutely no way we can cover every single one of them in this short presentation. That's just included for your reference in there. Oops, too fast. For those of you who are using automation integrations, again, I just listed some of the popular ones: Ansible, Puppet, Terraform, SaltStack. So we have connectors for those platforms. So by all means, we also have plenty of articles. It's like especially on our blog, Couchbase blog, and like this top one actually is the representation of that. Our blog is really good for just going in, checking out some of the step-by-step instructions on certain topics, like in that particular case on how to deploy Couchbase using Ansible integration. All right, so monitoring, that's where I want to spend most of the time. It's like I already assumed that we sized our cluster properly, we did the installation, and we get into the fun with monitoring. If you guys ever worked with Couchbase, and again, some of you may be new to the platform, you will know that in our web console, we have about 140 plus different statistics. So the cluster constantly keeps track of them, shows them to you in the web console, and they're also available over REST API. So if you want to keep track of certain cluster metrics, and you want to integrate it with some existing monitoring solutions, that's what the REST API is for. So some of this, I'm going to do a little demo here. Well, just to kind of open my two-node cluster and see how these statistics apply. But let's take a look at some of the stats first. So again, after we sized our cluster, we started working with it, started loading some data, working with it, etc. We need to watch if our sizing is actually proper, and if your data experiences the unexpected growth, you will have to add different types of nodes. So a typical example would be like Pokemon Go. A few years ago, I'm pretty sure some of you and your kids played that game. So Pokemon Go used Couchbase for their user profile store. And they, as you know, the game went viral, became really popular. And this is exactly what their Couchbase DBAs were doing. They were watching their cluster, and they were adding the different types of nodes depending on whether the data dimension of the cluster was growing, or the queries, or the need to add more indexes. So these particular ones, let's say for the balanced cluster, as I mentioned, active vBuckets should be equal to replica vBuckets, and we're going to take a look at that here in my cluster. So again, in order to get to our statistics page, for those of you who haven't worked with that, you go to the buckets, and these stats are collected on a per bucket level. So for this example, let's take a look at the statistics for the travel sample bucket. Okay. As I mentioned, there is about 140 plus of them. And if we are talking about the vBucket resources, it's going to be under your vBucket resources section. So right now, it looks correct. So I have 1,024 virtual buckets, and this is how Couchbase partitions your data. So it takes all the files that you put into one bucket, and it splits them into 1,024 vBuckets or shards. Those are represented as files on your file system, Linux, Windows, and they are scattered over your data nodes. Now the replica vBuckets, so right now with the two-node cluster, I can only specify a single replica because our distribution algorithm will never put the replica on the same node where your active copy of the data is. So in order to have at least one replica, you need to have at least two nodes. So this is what I have in this cluster, 2 nodes, and one replica is enabled on this bucket, and this is why we have 1,024 actives and 1,024 replicas. If I had 2 replicas with more nodes, that would be 1,024 replicas times the number of replicas you defined, and it can be 1, 2, or 3. Okay. So what happens if one of the nodes fails over? And by failover, we basically mean one node becomes unavailable, and we promote the replicas that were lost with that node, the replicas of the active data that were lost with that node, we promote them to be active. So instead of having 2 nodes here, now I have 1. And the replicas on the second one, well, I will actually have 0 replicas, because half of them were lost with the node itself, and half of them were promoted to be active now, just so that you have the 100% data availability. So if I come back in here and I check my statistics and I see there is a discrepancy between actives and the replicas, that's going to mean that one of the nodes is not available, or maybe more than one. So pretty important to keep track of that, although I'm pretty sure a good DBA would know that some of the nodes are down before even coming here. Okay, enough RAM. Since Couchbase is the memory-first system and your performance directly depends on how much data you have in the RAM, it's a good idea to keep track of several different metrics that actually talk about RAM. So active document resident, this is on the summary bucket. It's right here. So 100% is the best, which basically means all your data that you have in the bucket is currently in the memory. all your document keys, all your document metadata, and all your document values. So everything is served out of the memory, everything is updated in the memory, so you will have the best performance that you can get from your cluster. As your active document resident percentage goes down, you should actually watch for it and see, again, depending on your use case, what's the acceptable resident percentage. At this point, for Couchbase 5.5 and previous versions, we recommend that you have, at the minimum, 15-20% resident ratios. If you go below that, your cluster will still work. But number one, you will see that some of the performance starts suffering. And number two, if you have to do the rebalancing on the cluster, it may actually be a bit difficult because rebalancing also needs memory. And if most of your memory is already taken over by your documents and keys and metadata, then there's not enough left for effective rebalancing. So right now, it's the best practice is about 15-20%. And in the version 6 and 6.5, I'm pretty sure that we will be talking about that in some other presentations today. We are also working on the use cases which require a very low residence ratio. So as low as, let's say, 1% or even lower than that. A typical use case would be when you come to your bank. Banks usually are required to have 7 years worth of your bank statements, right? So what are the chances that you're interested in your bank transactions from back in 2013? Well, pretty low, right? But some people still do need to take a look at that. So in that case, we really don't care about having all that amount of documents, billions and billions of them in memory. But if someone comes in, we want to be able to look it up, pull it from the disk, and give it to the person who's requested. So initially, Couchbase was not really tailored very well for such scenarios, and that in 6.0 and 6.5, we are going to be making some changes to address those scenarios. For now, 15% is really the minimum that you should be shooting for. Low watermark and high watermark, these metrics, they are the really good measures to watch for as far as memory usage and compare them to the actual memory used. So this one, in this example, my memory used is showing 149 megabytes, and the low watermark is 150. So as I start using more and more memory, I'm going to go through that low watermark, and that's going to be my first sign that maybe I should think about adding some extra data nodes. The moment it starts hitting high watermark, Couchbase will start evicting documents from memory because basically it just needs to vacate some of the memory for the incoming documents, for the new information. So if you consistently see that in your cluster you're bouncing between low watermark and high watermark, it's really a good idea to start thinking about adding some extra data nodes. So I can quickly show what I mean. This particular query is going to grab some of the documents from my bucket, modify it a little bit, and just reinsert them as new documents in the bucket. So it basically will create more documents in the bucket. Let me execute this. Go back to the buckets, and you will see that this number 175,555 will start changing because we actually insert some new documents in there. Anytime now? Well, apparently it's doing some ops per second, but there you go. Okay, it's changing. So if I go back to my statistics, I can actually see, or you should be able to see, that my memory used will actually be hitting the low watermark, and Couchbase will have to make some, I don't know what's happening with my tiny little cluster that I'm running here, but well, in theory, that's what's supposed to actually happen, right? It should go through the low watermark, and you know, if I insert in enough documents, it should actually start hitting the high watermark, and the ejections will start happening. Apparently, it's not happening here, so let's just move on. So a few other things to look out for. So as far as RAM goes, so cache miss ratio, there's another metric. Cache miss basically means that your client requested the document. This request came to the cluster, and the document was not in the memory. So now Couchbase is forced to go to the disk and read that document in the memory and then serve it back to the client. Some amount of cache miss ratio can be okay, right? Especially if you have lower than 100% residence ratio. But if your cache miss ratio exceeds 1%, so basically out of 1 million requests, 1% of them should actually go to the disk to retrieve the documents. Again, this is a good indication that you may not have enough RAM. and number of disk reads corresponds to cache miss ratio. So it's like when you have a cache miss, you're going to have a disk read. So want to keep them both low in order to get the best performance out of your cluster. Okay, so here we took a look at balanced cluster, enough RAM, quite a few of them. Now, fast enough disks. So the way Couchbase works is we say that we're memory-first architecture. So any data mutations, inserts, updates, deletes, they first come to memory, and then they get into several queues. So one queue is the replication queue, which basically we need to create copies of those documents and put them into different nodes. And another one is disk queue. So disk queue is used to kind of level the load, the write load on your cluster. And disk queue is where your documents go before they actually get persisted to the disk. Again, typically that persistence takes just like a fraction of a second. But if you have the write-heavy scenarios, or if you're doing the initial load of the data, or maybe you have like the recurrent loading of the data, like on a weekly basis, this is what can happen, right? Your disk queue may actually grow, and the documents will not be persisted to the disk in a timely manner. So what can happen in this case is if one of your nodes with the disk queue goes down, those documents that are in the disk queue will not be persisted and they will be lost. Okay. So again, a good idea to keep track of the disk queue fill. Fast enough disk is really what kind of tackles that problem. So we're talking about disk I/O, whether it's on your bare metal or in the cloud. So if your disk queue fill rate is high and the disk queue drain rate, how fast the data is actually getting persisted to the disk, is not keeping up with the fill rate, it may be a good idea to kind of get the faster disks, something that is about 10,000 plus RPMs or SSDs. Now, if you're using, disk space, size your disk at least twice the expected data size. Again, it's kind of a rule of thumb. And the reason for that is, since Couchbase uses this append-only structure, right, like the append writes, we're not looking for a document on the disk to update it. We're just kind of writing the new version of the document at the end of your queue. So that append structure provides us with a very fast performance when the documents are changing, right? But it needs to be compacted, because over time, the old copies of the documents will be in that structure, and it just needs to be compacted. Just like defragmenting your drive on Windows. I mean, everybody watched that little utility do its magic and just moving little pieces here and there. So when the compaction process is started, whether it's manual or automatic start of the process, you will need enough disk space to write that new structure and eliminate the fragmentation in it. So that's the reason why I say at least twice. Again, 20–30% more than the expected size may be okay for you, but rule of thumb is just kind of give it twice the space that you think you'll need to store your data. And if you're using XDCR, the cross data center replication, again, depending on the number of documents that you replicate from one cluster to another, it's a good idea to watch your inbound and outbound queues. Because again, maybe because of some either the excessive conflict resolution or just like a very high write rates, those queues, that's yet another queue if you have the cluster-to-cluster replication, those queues can be filled up, and the result of that is the documents from cluster 1 will not get timely to the cluster 2, and you will have consistency problems. So REST API, as I mentioned before, REST API is used for pretty much all the aspects of cluster management and monitoring. So all the stats that you see in our web console, they are driven by REST API. So every single stat that you see there, you can retrieve by doing the REST API calls. And our documentation goes into the detail on every single one of those 140 plus different metrics that we keep track of for you. So again, you can plug them into your custom monitoring solution very easily, as long as they can do the REST API call and retrieve it. So that was the second point on a web console. So some of the command line utilities also use REST API. The idea behind that is we have the single source code base, and if we change it, the behavior changes in the REST and CLI. Some of them don't, just like a backup, for instance, because it's completely different. Now, one important thing to mention, and again, our documentation guys are doing really their best to fix this, but you will notice quite a few times in our documentation, and if you go and watch some older materials for Couchbase version 4.x, very often when we give you the example of how we run the REST API or command line utility, we do not include the authentication information in there. And the reason for that is in Couchbase 5.x, in Enterprise Edition, we added role-based access control. So it is mandatory now to submit the username and password for any operations that you want to do with the cluster. So again, some of the documentation reflects that, some of it doesn't. So sometimes you look at the documentation article and it seems like it's optional. It's not on 5.x. And here's just like a quick example of running one of those utilities in, let me see, there you go. So pretty popular utility, CB Stats. It allows you to kind of look into many different aspects of your cluster and node health. So this particular line, or this particular command runs and takes a look at the timings. And the timings, it's a histogram of how many different requests were served in what period of time. So when we're talking about sub-millisecond performance on the majority of our requests, this is a really easy way to check if it's correct or not. So like store CMD, for instance, these are the commands that are updating or inserting the documents. And it just gives you the range, right? From 0 to 1 microsecond, from 1 to 2, etc. So that's your histogram. And as you can see, within 1 millisecond, we actually serve in this particular case, 99.89% of your requests. So if you scroll up, like I said, it actually, even for the timings, it collects a whole bunch of different information. But so those were store CMDs, and like get CMDs, these are your gets. So same idea, we are serving basically within 1 millisecond, 99.99% of the requests. Out of, well, in this particular case, 83,837 total. So it's really interesting to look at these stats on a really large cluster that's been working for a while, where you have like millions, if not billions, of documents, because this number is going to be much larger, but the histogram is going to be pretty similar. So like most of your requests will be served in under a millisecond. And if that's not the case, chances are you do need to add some more memory to your cluster, because it actually goes to the disk and doesn't serve them fast enough. Okay, but in addition to just talking about this cool thing, I wanted to mention that right there, username and password. So it's included right now, and if I get rid of it, I won't be able to run that command. We used to be able to run it in 4, because 4 didn't have RBAC. In 5, it's not the case anymore. All right, so CB Stats, that was the quick demo of that particular example. It's what you can do. You can do lots of other cool things with the CB Stats utility. Again, documentation link is included. So for CB Collect info, if you worked with us for any extended period of time, and if you experience some issues with your cluster, you would know that this is the utility that we run to collect a lot of information from your cluster, to be able to troubleshoot what's going on in there. So if you're using Enterprise Edition and there's an issue there and you open the support ticket, in our user interface, there is actually a part where you can go and collect your logs. And under the hood, what it does, so let's see, it's logs. And you can collect information. So under the hood, if you specify all the nodes, and you specify that you want to upload this to Couchbase for our support to work with. So there's the customer info, and you click on Start Collection. What's going to happen behind the scenes is the CB Collect info will be run on every node that you selected. It's going to collect about 40 plus different logs right? The expanded information for every node looks somewhat like this, right? So that's just for one node for one of our customers that we're currently working with. And it's going to upload all that to our support. So thankfully, our support guys have plenty of their own in-house developed tools that allow them to work with all those logs very efficiently. So they don't have to go and look at every single one of them and to extract the information. Actually, does pretty cool stuff there automatically. But this tool is still available for you if you want to troubleshoot yourself what's going on with a particular node or your cluster. So again, CB collect info is one of the most important diagnostic tools. It collects a lot of information Couchbase related, OS related, and pretty much anything in between. And it allows you to kind of have the full look into what's been going on in your cluster. We did have a few customers who decided to kind of optimize this and change the login level, the default login level in Couchbase. Don't do it, because like if you encounter the problem and you run the CB collect info, the important statistics may not be there for you. So happened before, not a good idea. Defaults are there for a good reason. Okay, monitoring integration. Again, these are some of the monitoring systems that we work with. There's probably about a dozen more than this, but these are just some of the popular ones. AppDynamics, New Relic, Chef, Nagios, and Datadog. So if you guys work with any one of those, there are actually plugins available for Couchbase that you can use. All right. So if you, again, if you work a lot with Nickel, whether from the DBA perspective or from the perspective of the developer, those colorful books, I don't see them, like some of you have them, right? Those black books that talk about Nickel, the practical guide, and the Nickel guide to Couchbase 5.5. One of them we were distributing here at the Last Connect conference, and people came to us and said, well, the book is cool, but copying 2 pages worth of Nickel code is not as much fun. So for those of you who don't enjoy that, I mean, we have the PDF versions already there on the site, and again, the links are included. I mean, enjoy the book, but if you need to copy and paste something, the PDF versions are definitely pretty useful for that. And indexing best practices, we have a great article by one of our engineers on our blog. Again, you can go in there and just look and see which indexes can work better for you and for some ways to do the index optimizations. Okay, so with 5.5, we introduced our eventing service. And again, since it's kind of the new member of our generally available technologies, best practices are still kind of being shaped, right? So again, in our documentation, we have the eventing overview, which talks about what it is. In just a few words, eventing service gives you the ability to create functions in JavaScript, save them in your cluster, and execute those functions when a particular event happens on the bucket. So basically what it does, it looks for document mutations, for any inserts, deletes, or updates to a document. And if a particular condition is true, if that function catches that, then it can do certain things. It can update related documents. It can create a timer event. So for instance, for your document retention policies, if the incoming documents have the TTL, the time to live or expiration value of 30 days from now, maybe you want to schedule a notification that sends you a message kind of a week from when that when that expiration is due. So you kind of get the heads up, and you will be able to do something about that if you have to. So those functions are stored in a separate bucket, the metadata bucket, as well as the checkpoint information on when was the last time the function did something to the data. So with that in mind, right, with that kind of basic layout, the eventing services use that separate metadata bucket, so do not flush that bucket. Do not just manually go and delete everything from there, because that will kind of interfere with how your eventing services works and processes data mutation. Don't use that bucket for any other applications, right? It's just specifically for eventing services. Now, the functions that you deploy, they may lead to cascading writes, so just keep track of that. I mean, you change the document, a document change arrives. The function looks for that, so, okay, I'm gonna change, based on that change, I'm gonna change some related document. And if you have the function that is looking for the change in that related document and is gonna do some other changes, it may become messy, it may become really difficult to troubleshoot. So again, don't do that. One thing to keep in mind when you're processing your events is that Couchbase Server deduplicates multiple updates to your document. So if your application is making like 3 different updates to your document within the period of like a couple of seconds, what can happen is that those updates may get combined or deduplicated, and our DCP protocol, the data change protocol, will see it as just one change. Again, something to keep in mind when you write in those eventing functions. And in order to help you develop those functions, we have the debugger. Just kind of don't use it in production, common sense, but that's what we have for now on eventing services best practices. I'm sure we're going to have more as more customers start using it. So Couchbase, apart from Couchbase Server, also has the mobile components, the Couchbase Lite and Couchbase Sync Gateway. So if you're using your Couchbase Server for that, just a couple of things, a few words, best practices. Couchbase Sync Gateway takes care of moving the data from your mobile clients to the server and back. So if your Sync Gateway is responsible for doing that replication data, and you're planning to use XDCR, there may be some scenarios when those two guys will start conflicting. So again, I don't know how many of you actually use Couchbase for mobile use cases, but again, depending on your particular use case, the XDCR replication and Sync Gateway, you may just take a little more of a careful look of what exactly you are doing and choose one over another, but not use both at the same time. Okay, and maintenance, again, there's general info on Couchbase upgrading, some upgrade strategies in detail, like things when you can do the swap rebalance, a swap upgrade, so that introduce X number of new nodes into your cluster and remove the same number of nodes. In that case, your rebalancing is going to be very effective. It will just move files from one node to another instead of just kind of cross-moving them among multiple nodes. So that's all in documentation, actually pretty well described because we've been doing that for quite some time. And security. So for those of you who for whom it's really important, the installation and operation security, as well as the big white paper that we released this year. The GDPR became a really big thing in Europe, so that was the reason for that white paper release. So that's for you guys to look at and check how the security works and the best practices. So we're done with all the 4 verbs, and drinking is the last one, right?
Well, before we go drinking, I think it'd be an opportune time to ask any questions. So I'm here with the microphone. Anybody have questions? I got one up front.
Okay.
Hi, thank you for the presentation. So I have a scenario here. Let's say I have 3 data service nodes, right? I have a replication factor equals 2.
Okay.
And let's say I'm using just default durability mode, right? I have the server 1, right, which hosts a vBucket, a primary vBucket, right? And before the data is replicated to, the replica vBuckets, right? This server is down.
Okay.
So I have the server 1, and it hosts, let's say, a vBucket, 20, right?
Okay.
And before this primary vBucket replicate the data into other 2 replica vBuckets 20, right? This server 1 is down. Okay. So when then what will happen is that like the other 2 servers still running, one of them will be promoted to be the primary, the server for the primary vBucket for this vBucket 20, correct?
Okay. Yeah.
So apparently in this scenario, we will see data losing, right?
Correct. Yes.
So where can we find out? Is there any alert from Couchbase telling DBA, okay, so the data was not in sync before the server is down.
No, I don't think we alert you on every. I mean, you will get the alert because your node went down.
Yes,
right?
but I don't know if the data is lost.
So in this particular scenarios, like if replicating your data is really important for you, right? The SDKs as well as our nickel queries have the different levels of consistency that you can specify. Right. So by default, the consistency is like your application writes a document to the cluster. The moment it gets to the memory of the node, you will get the confirmation it's okay.
Yep.
We got it, right?
Yep.
But in your particular scenario, if it made it to the memory, but it didn't make it to the replication queue and node went down in that particular time, yeah, there will be a data loss. So in order for you to make sure that the data was not just written to the memory, but also replicated once or twice, right, depending on your use case, you can use the additional method that is called replicate to. And
Yes.
every SDK has that available. It's
Yes.
going to be a performance hit because
Exactly.
your cluster will actually need to wait until it replicates and then send the confirmation back to the client.
Right.
So.
Right. So one in this row.
Ooh.
Few in this row. Lots of questions. Let's make them quickly.
Hi, so I saw in Couchbase that we have the ability to send email alerts on a specific set of parameters there.
Correct.
Are there any plans to have Slack integration into that? Our company uses Slack quite a bit to get immediate.
I haven't heard about our plans for Slack integrations. Like Couchbase guys in the audience, if you've heard otherwise, that'd be great. No. But no, not yet.
Okay, what's the best practice to determine to use failover or remove in the situation?
Okay, well, those are two different operations, right? So when you click the remove button, what it actually does, it marks the node for removal, right? And it's waiting for you to execute the rebalance operation. The server continues serving the documents and saving the documents and working just as it used to until you actually execute the rebalance. So that's how remove works. So even though you click the remove button, it doesn't mean that the server is no longer part of the cluster. Now, if you click the failover button, it's basically the same as pulling the plug from the outlet, right? That server is not going to be available. But I mean, it gives you the option of whether doing the graceful failover, just kind of waiting for all the connections to be completed, right? Served from that node, or just hard failover, which basically means pulling the plug.
So with the failover, the replica will kick off right away. So like if I pick the failover.
Correct. If you fail over, the promotion of the replicas will happen right away. With the remove, that's not the case. Right?
Okay, thank you.
So a quick question on, you said less than 1% cache miss, right? So the cache only carries metadata, is that right? Or is it just?
Cache miss basically means that the request came to the memory, it was looking for a document there, but the document value was not found. So now the Couchbase needs to go to the disk and read that value into the memory and then serve it to the client.
The best practice is less than 1%
Correct.
cache miss?
Yeah, I mean, the fewer the better, right?
Yeah,
but
but
definitely keep them under 1%.
Okay, so that doesn't mean like 99% of your data should be in memory, right?
No,
it's just the
doesn't mean so.
metadata, the keys, right?
Okay, well, the metadata in the keys will always be there if you specify the value eviction policy on the bucket. Okay. They will always be there. Okay. Right.
So you said like in 6.0 and 6.5, the memory ratio could go up to 1%. Currently, you advise like we should have at least 15% data in memory, right?
Correct. So one of the big things for 6.x, one of the big things that we're doing is addressing those low residence scenarios. So until that happens, it's still a good idea to just keep your residence ratio at 15% or higher.
Yeah, I'm okay to have like 5% or 10% data in memory in my normal BAU case. But what will be the impact of rebalance if I have low data in memory?
Well, basically, the effect of the rebalance needs to use a part of your memory, okay? And if that memory is not available, the rebalance may be either very slow or in some really bad cases, when the memory is completely taken over, it may actually hang or kill one of the nodes, right? So that's why. It should be addressed, yeah. We'll see what our great product management guys will come up with. So I'm eager to see that myself.
You mentioned there were some potential data collisions with using XDCR with Sync Gateway.
Correct.
Is it possible to isolate that to say that Sync Gateway is only for bridging to SQLite, listen, Couchbase Lite and like a primary data center, and then XDCR to a replicated data center?
Of course, yeah, you can do that. So it's like, and again, if the particular concern would be if you employ the bidirectional XDCR and Sync Gateway that is writing to both data centers, right? So if you write into predominantly to your main data center and you have the unidirectional XDCR going to the other one, that really shouldn't matter, because I mean and this is for your like disaster recovery scenario. You really are not using your second cluster; you're just keeping it just in case. So in that particular use case, you're fine, right?
Hi, just a question. I don't know if you have this already, but for if I want to do my own sort of monitoring, typing the curl commands or using it's great you have the REST API. Could you provide a suggestion? Could you provide a Swagger specification for the REST API? So if I wanted to create my own client using like Swagger CodeGen or something.
Do we have it? Swagger specs? I don't know if we do, but if you guys can take down that questions, like I'll look up the answer.
I could write my own custom
you
monitoring.
can you can definitely use curl with our REST API, but yeah, Swagger. Good question.
We are using AWS for Couchbase. So are there any like good practices for authenticating Couchbase users? Because we wanted to implement Active Directory integration for users authentication.
Okay.
Because it's very difficult to maintain users, enforce password policies and all those things if we don't have one.
So Enterprise Edition of Couchbase has had the LDAP integration for quite some time, but there are some improvements that are coming up. One of the things that people were asking is to integrate with LDAP groups. Because if you specify a group and you assign your customers in there, then we just want the same group to be on the Couchbase side. Right now, it's basically user for user. We don't work with LDAP groups just yet, but as far as I remember, this is something that is scheduled for 6.x, so it's coming.
I have basically two questions. One is like regarding authentication. We are using Couchbase 4.5, and the password rotations basically is taking a downtime now.
Okay.
So is there any way, or in 5.5 or 6.0, is there any way that without any downtime basically to the bucket, can we change the password?
Well, the bucket passwords disappear completely in 5.x. They are no longer there. So when you're doing the migration from 4.x to 5.x, what we do for compatibility reasons is we automatically create a user with the name of your bucket. And we take the password that you save for your bucket and we assign it to that user. So that's for migration. But from that point on, it's actually, it's easy for you to have different users or different groups and assign different passwords for them. It's like I would expect if your application is using a certain password and you change it, and you kind of need to synchronize the change on the application side and Couchbase, of course.
One more question. You had your hand up. I know, that's okay.
Question about the compaction. So in the compaction, what are the strategies that we are using? TTLs, different strategies of compactions. Do we have a hand on how to specify what type of strategy we want to for the compaction, or?
So there are ways to specify it in Couchbase, both through REST API and Web UI. So on, let's see, I believe it should be in the settings. So your auto compaction settings are over there. So these are defaults, right? And again, defaults work for many use cases, but not for all of them. So by all means, you can actually look up in our documentation and experiment with these settings, but change the default percentage of the fragmentation. So 30% is what's default. That's when automatic compaction kicks out. If you don't like 30%, if you have enough disk space to kind of accommodate higher fragmentation ratios, you can do that. So higher ratio means fewer compactions, but you need more of a disk space to kind of keep all that defragmented data. So same thing goes for scheduling that at different times. So if you want to schedule it for off-load times, off-peak times, this gives you the ability to do that.
Terrific. Well, I'd like to thank, I know there's probably a few more questions. There always is. Oleg may be available. We're out for a break. But for the live streamers, I want to make sure I bring everything to a close. So, Oleg, thank you very much. A very informative
Thanks, everyone.
session. Thank you.